Yeah, good morning students. Let us start today's lecture number 5. We are discussing today about still factorization. One more question I am going to solve, then we will solve the infinite related questions. Okay. Now here the question is evaluate limit extending to pi by 4 1 minus sine 2x by 1 plus cos 4x. You have to find this. See, the logic behind this question is to make you understand these 2 points which are most important things. So 1 minus sine 2x, this is used as cos x minus sine x whole square. I told you this is most important one, right? And this is also used in integration many times. So remember that this is the most important case. So 1 minus sine 2x can be written as cos x minus sine x whole square. Reason is what? If I use here a minus b whole square formula, I get as cos square x plus sine square x minus 2 sine x and cos x. A minus b whole square formula. And you know that this value is 1 and 2 sine x cos x is nothing but sine 2x. So 1 minus sine 2x can be written as cos x minus sine x whole square. And next one is 1 plus cos 4x. 1 plus cos 4x can be written as, I already informed you, this is also most important formula, and we can write that is 2 cos square 2x. And you know that cos square 2x, cos 2x formula, it's a square, right? I know cos 2x formula. What is cos 2x formula? Cos square x minus sine square x, correct? So this is can be written like this. So this is one of the good questions of factorization. So we can use this limit extending to pi by 4, and we can write the numerator as cos x minus sine x whole square divided by 1 plus cos 4x can be written as 2 into cos square x minus sine square x whole square. This is what you have learned now. Now here, after what I can do, I can write as limit extending to pi by 4. I can write this one as cos x minus sine x whole square and 2 into, you know this is a square minus b square formula. That is, we can write as a plus b into a minus b. That's what we can write, isn't right? So this is whole square. I can write this is a whole square. It means that square I can separate to each one. So I am going to separate this one. I hope you are understanding. This is whole square and I am making one short, that is I am separating the square to each one. So therefore you can see this cos x minus sine x whole square, cos x minus sine x whole square is 0, also cancelled out. So what is left here? Limit extending to pi by 4, you get 1 upon 2 into cos x plus sine x whole square. That's what you are going to get it. So now what I can do here, I can find the limit extending to pi by 4, I can substitute in this. So therefore I get 1 upon 2 into cos pi by 4. What is the value of cos pi by 4? Just you keep cos pi by 4 plus sine pi by 4 whole square. I am substituting the limit in the place of x. So 1 upon 2 into cos pi by 4, you know 1 by root 2, and sine pi by 2 is 1 by root 2, and this is whole square, right? All you know that 1 by root 2, correct? So I can write here 1 upon 2 into root 2 is the LCM, so you get as 2 upon root 2 whole square. And you know that this is can be cancelled root 2 times. This is can be cancelled root 2 times. So what I get, a 1 upon 2 into root 2 whole square, and square root cancel out. So therefore I get 1 upon 2 into 2, that is 1 by 4 is the answer. So this is a way to solve this question. Hope you have understand. Let's see the next question. See dear students, I just want to explain one more question on rationalization. See here, I already discussed in lecture number 4 rationalization and factorization questions. Now one more question on rationalization. So with this video, rationalization, factorization questions are completed. and I given the homework. Please post your answers in the group. Okay, this question I'll finish it, then we will start some standard limits and infinity problems related to limits. Okay, let's see here. Limit x tends to a square root of a plus 2x minus square root of 3x upon square root of 3a plus x minus 2 root x. You have to simplify this, evaluate this limit. If I substitute a in this, I get as square root of a plus 2a, that is square root of 3a minus square root of 3a, that is I am going to get on the numerator 0. If I substitute here a here, square root of 4a minus 2 root a, that is I am going to get 2 root a. 2 root a minus 2 root a is 0. So it is getting indeterminate form 0 by 0, right? So we are discussing 0 by 0 form all questions right now. And the next lecture we will discuss about infinity by infinity questions. Okay. So I told you all indeterminate forms. In that, infinity by 0 have finished. Now next lecture we will start with infinity upon infinity. All indeterminate forms we will solve it. Okay, let's see at this one. Whenever you get 0 by 0 form, you have to rationalize here. But see that numerator also you have square root and denominator also you have square root. Whenever you have numerator and denominator in square root, you have to rationalize twice. So rationalize twice, that is the concept in this. So what we use here, limit x tending to a, square root of a plus 2x minus 3x upon under root of 3a plus x minus 2 root x. I will multiply and divide with under root of a plus 2x plus root 3x divided by, see here, what I do here, I will rationalize this, So for this rationalization is plus, because square root of a plus 2x minus square root of 3x, rationalization factor is square root of a plus 2. This minus will change as plus, that is the rationalization factor of numerator. So numerator rationalization factor I am writing here a plus 2x plus root 3x, and I am doing the denominator rationalization factor also. So that I get as under root of 3a plus x plus 2 root x divided by under root 3a plus x plus 2 root x. Remember this. Now what I can write here is limit x tending to a. Look at here. Look at the picture. These both are looking same, that it's appeared like a minus b into a plus b. We have the formula a square minus b square. And look at here is that these two pictures are same, like they are following in a factors rule, that is a minus b into a plus b, that is a square minus b square. So we have to apply that formula, correct? So when I apply this, I get as square root of a plus 2x whole square minus under root 3x whole square into the rest of the thing is left is square root of 3a plus x plus 2 root x, isn't right, divided by this is these two I multiply, I get as under root of 3a plus x whole square minus 2 root x, this is I can write 2 root x whole square into I can write as square root of a plus 2x plus root 3x. This is what we have. See, the alone one point here, the alone one point is here, and these two products has made a square minus b square formula. So square root cancel, square root cancel, square root cancel, square root cancel. Okay, here don't do like this. I'll write this step. So therefore I can write here limit x tending to a. I can write here a plus 2x minus 3x into I can write here square root of 3a plus x plus 2 root x, isn't right, and here square root cancel, I can write 3a plus x, and this is I can write as minus 2 square is 4, root x square is x, that is I can write 3 here. This is what I can write, isn't right? Thereafter, so hereafter square root of this is left, and then you can write under root of a plus 2x plus square root of 3x you got. Hope you have understood this. Yeah, am I right? Yeah. So therefore, on the top, what I am getting here, we can write the steps. I'll write the step here. Limit extending to a, on the numerator I am getting a minus x. See this, I am getting a minus x, and the square root bracket I get under root of 3a plus x plus 2 root x divided by, here I can write as 3a minus 3x, and I can write under root of a plus 2x plus square root of 3x. See that I can take 3 common out here. So I get a minus x, a minus x, a minus x, a minus x cancel out. Limit extending to a. So if I take a minus 3 common, I get a minus x cancel out. What is the remain? You write down that. Square root of 3a plus x plus 2 root x divided by under root of a plus 2x plus under root of 3x. So 3 is left because this a minus x cancel. Now you can substitute the limit. If I substitute the limit a plus, now you substitute under root of 3a plus 2 into root a divided by under root of a plus 2a plus square root of 3 into a. Correct? So thereafter I am going to get this 4a, root 4a can be written as 2 root a plus 2 root a divided by, here I get as root 3a plus root 3a. This is root 3a and this is root 3a. I can write as 2 root 3a, and root 2a I can write as 2, I can take in common, 4 root a. I can write as 4 root a upon 2 root 3a. So see this, 2 1s are 2 2s gets cancelled. Root a gets cancelled, because if I separate this root a, I can write as 2 root a upon root 3 into root a cancel out. So the answer for this question is 2 by root 3 is the answer. So this is the way we have finished rationalization and factorization questions. Now 0 by 0 form we have completed. The next indeterminate form we are going to discuss infinity by infinity. Now we are going to start next topic, infinity by infinity.